Hi guys, there was a request to go over the Sankey diagrams a little bit more. So all these are doing is just giving you a visual representation of where energy flows. Here I've done a simple or a Google image search for simple Sankey diagram, and you can see a bunch of different examples. Some are really simple, like this one here. Just shows 100 joules of electrical energy going in. 75 joules of that is going to actually light what I assume is a light bulb, and 25 joules is lost to heat and energy. You can have more complicated ones, like this one is showing, there's actually like a feedback loop going on in this one. So they can be more complicated, but on the whole, it's really just a way of showing where the energy is flowing to. So Sankey diagrams typically show flows of energy, but they don't have to. Like in this was a student example that compared where the milk goes in their house. So they're saying that out of 60 ounces of milk in their house, 10 ounces is used for coffee, 40 ounces is used for cereal, and another 10 ounces is used for drinking. And you can kind of see how the size of these arrows is representative of what proportion of the total it's representing. So this is another one using energy, but instead of having actual amounts of joules of energy associated with it, it just has percentages. So it's saying if I had some amount of coal, that coal has a certain amount of potential energy in it. And when we burn that coal, we release that potential energy and it goes into these different avenues. So for example, according to this diagram, let's add some numbers in here. Where's my pen? So let's say I started out with 500 joules of potential energy stored in some amount of coal. So according to this, if I start off with that, out of that total of 500 joules of energy, I'm actually going to lose almost half of it, 45% of that 500 joules to heat or thermal energy. So that's going to come out to about 225 joules to heat. I'm going to use up 10% of that energy in the power station. So that's 50 joules of energy there. That's supposed to be a J. Another 10% is going to go to the generator. So that's another 50 joules. And out of that coal that I'm burning, I'm actually only getting 35% of it converted into electrical energy that we can use. So I'm only getting 175 joules of electric energy out of that. And then one more example. So this is a student example applying it to eating food. So we have it looks like they're starting off with about like 6 million joules, it looks like, of energy from the food. And then they've broken this up into, okay, 60% of that energy that the human body got from eating the food is going into thermal energy to keep the body warm. Another 20% of that is supporting the nervous system. 15% of that is going into friction or motion. And then this last one is a little bit, I think that might say digestive. So that's how much energy they're using actually digesting the food. So on the assignment today, you can, for the first part, you're just finding an example from the internet and copying it. Doesn't have to be an overly complicated one. And then I've given you that picture of a cell phone battery with the different percentages. So you're going to end up drawing something similar to this, but just showing the larger percentages are going to be a larger section arrow, and then the smaller percentages are going to be smaller section arrows like you see down here. I know the last few are like 1%, so if you wanted to combine a couple of them into like an other category, you can do that too. Email me if you have any other questions. I should be checking my email fairly regularly the rest of the day.